So reading, a screenshot it or something. Again, reiterates, reinforces functions, what we're going over this week. Chapters 10, 11 on modern C++ this week was on declarations and functions. And then chapter 9, this is on the variable scope and functions, is what chapter 9 reading is on. And then this link here is a link I put in here for strings, just because there's some functions in here it talks about, or string initialization, string manipulation, things of that nature. I think can be confusing sometimes when you're dealing with strings. So it's a good resource, I believe, for strings in general. And it does help you with this week's assignment, which has to do with counting words. So it has a number of examples of that in there, as well as reversing words, checking words for palindrome, checking words for uppercase, lowercase, extracting characters from left, right side of words. So it's a good general resource for strings in general. Recommend that definitely before doing the assignment. So do the reading assignment as always before you reading and links, any links I have in the reading before you do your assignment for sure. And then there's a few slides here I want to go over in chapter 9, which that is the chapter 9 from the practical C++ text. There's on variable scope and functions. We'll go over that real quick. We'll do a few examples, go over your take home, give you some examples of that to help you as well. A couple ways to do it this week. Okay, so scope, variable scope and class. We're going to focus mainly on this slides on the scope and functions, and how functions, global variables function in and out. Scope variables function in and out of functions, whether it's a local scope or a global scope. This is a montage screen, so apologize, that just came out weird. But at the top there, at the very top of the code, where it has int total, int count, notice it's outside the main. This would then be a global scope, all right, for these variables. Inside the main, you'll notice total and count is used and initialized, but inside the loop there, or inside the counter loop, the local count is also initialized inside the brackets there. So int count equals 0. That's a local counter. While count less than 10, increment by 1. And then global count here is hidden because of that. So when you have a global count or a global variable, the local variable within a loop, which is generally when it's used, or a for loop or while loop, is going to supersede or hide, really technically better worded as hiding, that global count. And so be careful when you have counts, just be aware of that. You can use global counts, just use them sparingly. I think counts for programming, for the way I use it most of my life, has been for data records, keeping account of that from screen to screen, to username is an example, keeping that variable alive as a global. That's about it. I mean, there's a lot of other uses. Those are top 2 uses, definitely, that are used in programming. Tons of other uses, but you just don't want to use a global for everything. If you can get away with not using a global, don't use a global, if that makes sense. So you want to limit the amount of globals. And plus, your memory on your computer, 64,000 kilobytes of RAM can be used for global, even in 64-bit applications, meaning that sounds, it's a lot because most of your integers are 4 bytes and longs are, 12, 16, 18, 21, 1,000 bytes. But it can add up over time. If you have globals, a lot of globals in your app can add up and crash your app basically if you have tons of globals in there. So just limit the amount of globals within your app. Some of the other terminologies, variable can either be permanent or temporary. Permanent variables declared either as global variables or key using the keyword static, which we'll look at an example in a second, is initialized only once when the program begins and destroyed only once when the program ends. Temporary variables must be local variables, initialized each time they come into the scope of that function, destroyed when they go out of the scope of that function. And this mentions what I talked about earlier. Temporary variables are allocated from memory called stack on a PC, usually limited to 64K max, sometimes 4K. If you get larger than that, you get a stack overflow, resulting in allocating too many temporary variables. So here is an example of a permanent versus temporary. You'll notice in the for loop in this, or starting at the top, you have an int counter, which is going to be used within the main, and then a for loop. And inside the for loop, there's two variables right underneath the for, one called temporary and one called permanent. You'll notice a difference though on the second one is called static int permanent, meaning that variable is going to be kept alive and be kept permanent throughout the cycle. The temporary, you'll see, will be overwritten each time within the for loop. So in the example here, it's going to print out 3 times temporary whatever, permanent whatever. And since int temporary is a temporary, truly a temporary variable, it's going to die each time and be declared as 1 each loop. But notice a static int, when it, even though it's technically, you would say, declared each time in the for loop, because it's static, it's a permanent instance, and it keeps the values held in that variable by using the static int. And so that's why you have temporary 1, permanent 1, temporary 1, permanent 2, temporary 1, permanent 3. So anytime you want to use a static int would be perfect for, like, say, aggregating data, addendum of data, and totaling records, things of that nature. You're going to use a static int or static whatever variable type. That way, you know it's going to be kept throughout your for loop in the counts. So just remember that. Types of declarations. This is a good reference. Declared scope, storage class initialized. So on declared, outside of all scope blocks will be global. Storage class, and this is permanent, initialized once. So even though that static one was in essence visually initialized each time, it was technically only initialized once. It skips it in the compiler when it sees the word static, by the way. Static outside of all, global again, permanent once. Inside a block, a local variable, temporary, each time the block is entered, like that temporary one we looked at. Static inside a block is local and permanent once. So namespaces, this screen just talks about, when you're declaring a namespace, which we're not going into this week, but just kind of keep in your head. We will be going over namespace in the future. Namespace basically is going to be the name of your function or prototype that you're going to be using within your app. And up to this point, we've been using on functions, and starting this week, the name of a function is going to be either void, int, string, something like that, right? But we will get into what's called namespaces, which are allowed to be used throughout your C++ application in multiple different CPP files. And so that's important when you talk about namespaces. Just note that. So namespaces, special namespaces, uses the standard input, what we use already for cout, and they're global. By using a global namespace, the word global, it's going to allow that namespace to be used globally throughout the application, meaning multiple different file names or CPP files can use that global variable outside that file, if that makes sense. And so we'll be getting into multiples past half semester and be playing with multiple CPP files to show you that. Using statement, don't use that. It's imports variables from other namespaces into current code. So an example here is using a namespace foo and declaring to, populating full with to, and then importing all on the last one. And so just stay away from using, and we'll talk about why that is later, but just know, stay away from that, especially in C++ 11 that we use, which is modern day C++. Functions, will start when you're declaring your code, starting next week on functions, putting in this type of description of what the function does, just to kind of note within coding, how documentation is done within functions and modern day coding in a workplace environment. And you'll notice in here is a name of the function, which in this case, computing an area of triangle. The parameters, it uses width and height, and then returns the area of the triangle. And again, some functions are going to be quite lengthy in description maybe, and maybe short like this one. But it's good practice for documentation and also for your coding environment to start documenting things correctly. And so we'll start talking about that next week and having you use that in your code. Don't worry about it this week. And we don't talk about that. Passing and returning. We'll talk more about that in our examples tonight. Function prototypes, declaration. So just like variables, one of the questions in the little quiz was, just like variables, functions must be declared before they can be used. Typically what's called a prototype declaration. So here's an example of one: float triangle, float width, comma, float height. This function returns a floating point number, the first float, and takes the floating point parameters. It can also be written as float triangle, float, float. Usually frowned upon here because it doesn't tell the reader what the parameters are for. Even though the variable types are there, it doesn't help the reader know, or the programmer really, down the stream. It's also easier to make a first form by cutting out the first line of function and pasting it wherever you need to. Don't forget that a semicolon at the end. Functions with no parameter, still allowed in modern day C++. You can definitely do that. Where no parameters are allowed, maybe a print function or something, possibly, or that's a popular one, or gathering data function, something like that, where a function calls other functions maybe, but the function itself is a void in and of itself. It is a holdover from C, but still used quite a bit in programming, for sure, definitely. And you can hold any parameter type, which is nice within it. Usage, like value equals get value, functions that return nothing. Next would be a print answer. Usage print answer 45. And we'll end on constant parameters cannot be changed. And so, for instance, it's illegal to change the value of a constant parameter with equals 0.5 if it was made constant in initialization. And references, and we'll talk more about this as weeks go on, but keep in your head again tonight, two things occur when declaring a reference parameter. The top one's what we've been using thus far, which is a simple parameter of a variable. Second one is a reference parameter. And so you'll notice it has the and symbol before the reference equals simple. This is a reference parameter. Part one is a reference declaration in red. And then it's a reference parameter. The second part binds a reference to some variable, in this case, simple, which is a variable, not a value, but a variable. And so it can be used later on in the code for referencing, for pointers, for binding throughout the code. And so we'll get more into that as the semester goes on. But again, don't want to get too far ahead into that. Next. Over that. Okay, some examples we're going to look at. First is the function max min value. and then function pass by value. So if you click on that function max min value link and go ahead and run it, it says the max value here is 100. And let's look at the functions here. We have here the include statement, the namespace standard, function declaration, prototype, int max, int num1, comma, int num2. In the main, declaring a couple local variables, A and B, 100 and 200, and then a empty RET for returning a function value. Then RET equals max, A comma B. We'll look at that function in a second, and then it sees it out. Max value is RET, wherever that value is, then finally ending the program with return 0. So let's go to the max function. Int max, int number1, comma, int number2. Again, a local variable to hold the result. So if num1 is greater than num2, it's going to say, okay, that's the max number, else that's going to be the max number, and then return that result. So what I want you to do real quick is you're going to declare create a new function first on line 21 that returns a min value instead of a max value. You can use a logic for that function int max from 23 to 32. Definitely make sure you plug in there after that as well your prototype for that new function above. So take a moment to do that. And now on line 18, you'll call that function. That's to create a new 2 lines under line 17. Create 2 new lines like 15 and 16. One to get the min function call into. You can use the same variable RET. You're fine. You can use that. You're just going to call that new min function. You could also want you to have the same A and B. You're going to call those as well, just like they are. Call them max. And then just change your C out from max value to min value. All right, I'll go ahead and show you what I got. Fine, I declared my prototype first, which is int min, same exact parameters as for max, and then declared the function. I just copy and paste max, renamed it to min, change greater than to lesser than, everything else the same. Then in line 18 and 19, added the return min AB, just like max AB, and then changed the word min max to min, and that's the value got back. Max value is 100 or 200, min value is 100. Got that? And while I'm making the change too on this program, just so you know, it is saved in my replit. That way, if you go back and click on it later, the changes I just made are in there, should be in there for you to look at. I just refreshed it. Yeah, it's still in there for you. So there we go. Everybody got that? We'll keep it up here a little bit longer for you. So again, I declared a prototype int min, same exact declarations or parameters at num1, num2, and then copy and pasted the function max and renamed it to min, changed the line 27, the greater than symbol to lesser than symbol. And then in the main, went back in and called the min function, the same exact variable, ret, and changed the min value, max value to min value. Good. All right. Now let's go to the next one, which is pass by value, function pass by value. And so we run this. Says here right now the total value is 300, total value is 120. So let's see what's happening here. You'll notice at the top, it has a integer function with two parameters. This time, the second parameter is as a default called for 20 instead of nothing. Meaning, if they leave out that second parameter, the parameter will default to 20. So on the first, and then it'll kick back, by the way, regardless, that result, summing it together here in an integer back to the main. So we see in the local int main, int A is 100, int B is 200, and then int result will be used to plug in the sum. So int sum, int A, int B, I declared this as a int main prototype. Notice it's the same as the prototype above on line 4, whereas the actual function above. And then I call it on line 17, result equals sum AB, which I give them both sides on this, so it should come back that 300, which it does. And then second calling a function, I only put A in there. And you'll notice when I do that, it uses A for the A slot, the first slot. B, it gives 20 because I didn't put it in there, so it's 120. Now what I'm going to do is play around with, let's say if we do this. Let's see if we change the default from 20 to 30 for the for A, or default from nothing to 30, I'm sorry, for A. And you'll need to do this, by the way, in both the function and the prototype. And then what I want you to do is on line 25, you will call a function again with just sum B, and then comment out line 27, which will give the total value. And we'll talk about why it does that once it's finished. Some different things it'll do there. So we're just declaring it. We're actually putting in a default prototype or default value for A this time of 30. We're also doing the same in the prototype in the main. Okay. So what we did on this one, declared 30 for A, 30 for A, and the prototype as well. And I had you add the result B this time instead of A, and then total value. So what it did was, even though we put the default in 30, when you put B, it's going to, you'll notice B is what? 200, so it gives a value of 220. So what it uses was 20. So the reason I wanted you to do this was to show you that when you do a default, it only works for parameters after the first parameter. It only works for that. Won't work for the first. So you have to have at least one parameter. The first parameter has to be fulfilled with something. That makes sense. And so the second one, regardless if you even we can put whatever we want to on this default, it's not going to ever be used. As far as even if we call one, it's always going to go to the second one, which it does on this. And so just wanted to show you that. So again, this is passing by value though to that function each time. And just remember, when you declare a function and you change it downstream or you modify it, to also modify your prototype. Your prototype can be declared within the main or outside the main, either one. Now, if it's going to be outside the main, it's going to be used in multiple different subs or multiple different functions. For this one, it's fine to have it in the main because it's only used in the main. But if it's going to be used in multiple different functions, you can declare it outside the main. Yeah.
So I guess I don't understand why it doesn't add 30 to.
Yeah, good question. It's just a rule in C++ passed by reference in the language, in the SDK, that the first argument, it will always need an actual value to be passed by. So even if you put something in like this, it won't blow it up.
Sure.
You just will never use that first one as a default. It'll always be second.
Even though you say it.
Even though you say, if you put something in there and you forget one of those arguments, it's always going to infer that the one you put in there was for the first argument. Yep.
So it's almost going to negate that first one.
Yeah, exactly. Right. Correct. Yep. So I thought I'd show that to you because I like to blow stuff up like that sometimes. So kind of reverse it. Okay, so for your homework, I've already got it up here and some examples for you. Let's see. Boom, boom, boom. Let's do the link for that. So this one is a word count, I believe, right? And so I'll show you some different ways it can be done. Okay, so once you write a function procedure or just a procedure, either one will work for this one. Call from the main that counts the number of words in a string. In your comments, should describe exactly how you define a word. And a word is going to be something defined, basically separated by a space, in this case, in our argument, separated by space. In your comments, also describe how you check if the portion of a string is a word. Again, the space logic. So if you entered in hello REC students, you should have two spaces in there. It's going to separate it and it's going to count them with three. Couple links. One is this help link. The other is this example I'm going to show you here that I threw together that might help. And so here's an example of a hello world. You'll notice in here it's got the basic hello world, and then I have a declaration of the prototype count that brings in one char as an array. And then seeing out the numbers of words, count hello world. In the function is bringing in that array, declaring words as 0, and looping through each one of the array of that word. And basically what it's doing here is, while it's not end of line, is what this means. While it's not end of line, while that array is not to the end of line, it's going to keep incrementing. If it finds in an array space or an array loop a blank space, it's going to just increment the count of words, and then finally return that count, which I have returning words plus 1. And so right now I'll go ahead and run it again. So it runs it, hello world, number of words 2. So if I, type in hello world again, hello number of words 3, so on and so forth. And so for the logic on this one, again, single space, it does not denote for 2 spaces, just a single space. So just note that everything's hard coded in. And so that's all I'm wanting you to, that's one way to do it. The other way you could do it for a challenge, instead of hard coding in the call to the count, is maybe doing a CN to the call. And maybe on that one, just letting the user know when they type in the words to only separate it by 1 space. So in the description of that cout, separate your words by 1 space. Might be a good example. Okay. And then that way when it sends it, that would be a challenge for you to do it. And again, it's looping through. This is a new one to you on as far as looping through while that array is not equal to, and this is the end of line character for that, or end of the array character in this case for that array count of words. And it's going to keep looping until it's done. So how many words they put in there, this will surmise for that that ceiling, that array ceiling, whatever. So how many words they put in there. And again, this is hard coded in. Challenge might be to use a CN instead of a cout for sure. Make sense? You're calling it. And this is actually, I did put this in the example for you, I believe. So that replet's right there for you, and you can play with it and have fun with it. And again, for validation, for extra credit, for challenge, do CNs